Welcome to Chem 2005, the Chalk and Talk lectures, or summary of the lectures. And today we will talk about the introduction to the synthesis of heterocycles. Okay, heterocycles, as you will know, in 5-member heterocycles, but we have pyrrole, furan, and thiophene. Okay, if we go to the 6-member ring that we will see later in the course, we have, for example, pyridine. Okay, and then there are the fused rings. There are several other rings, but basically the important thing is that heterocycles have an atom that is not a carbon. Okay, and normally it's a nitrogen or oxygen. It's the most common products. For this reason, because we have nitrogen as oxygens, the reactions that we will use more often in order to synthesize heterocycles are the formation of acetals and the formation of amines, hemiaminals, or enamines. Okay, these will be the most important reactions that we will check. Easy example, we have here this compound, this aminoaldehyde. Okay? If we do an imine with this aminoaldehyde, what we have is this 5-member ring. As you can see, this will make the 5-member ring almost immediately. That means we will use this type of reactions a lot. And now what I will give you is a introduction, remember, say it as you wish, about the formation of acetals and the formation of amines, enamines, and hemiacetals. Okay, we will start with the formation of acetals. We have here a carbonyl compound that has to be an aldehyde or a ketone. Okay, R1, R2 could be carbons, could be hydrogen in the case of aldehyde, and we react with an alcohol. Okay, always the reactions to form acetals has to be in acid media. And the first step is always the protonation of the carbonyl group. Why? We do this in order to activate the carbon of the carbonyl group. Now this carbon is more electrophilic. That means that even a bad nucleophile like alcohol will be able to attack this activated carbon and obtain this intermediate that basically we lost one proton. Okay, and we generate the hemiacetal. What is happening next? We have to eliminate this OH. How we do it? Remember, OH is a very bad leaving group. That means that we will protonate first. And what we will get is this compound this now is water, is a very good leaving group. That means that will leave. We will get this carbocation that basically will be attacked by another alcohol. And then we lost the proton and we generate. We generate the acid. Okay? This is one of the reactions that we use more often in order to synthesize heterocycles. And now we will do the second reaction that we will do more often, even more often than this, that is the formation of imines, enamines, or hemiacetals. Okay? To form imines, basically we have exactly the same as before. We need a carbonyl group, basically a ketone or an aldehyde are the two options. Okay, and this time the difference is we add secondary amine, a primary amine. Okay? How is it starting? Again, it's exactly the same as before. We need to do these reactions with acid media. Okay? First step, we protonate the carbonyl group. Why? In order to do the same as before. We want to activate this position, this carbonyl position. Now, the amine is coming, pair of electrons are attacking this carbon that is very active. Okay? And what we get is this intermediate. We lost one hydrogen, and what we get is this compound that is the hemiamino. Okay, we are halfway of the final product. Next step, we protonate this alcohol that has to be eliminated. That means we are making this hydroxy group a good leaving group. Okay? And simply the water departs we generate this carbocation, and then simply the part of the nitrogens are forming the double bond. We lost one proton, and what we get is we get the imine. Okay, that means hemiaminal imine. This will be used hundreds of times in this type of synthesis of heterocycles.